Good morning, guys. This is Mr. K. Wood. I hope you had a restful spring break as much as you were able to. If you hear some funny noises in the background today, that's because my wife and I got a puppy over spring break last Monday, and he's in the office with me munching down on some food right now. It's a little after 7:30 this morning when I'm recording this, and so he's eating his breakfast. So please forgive any crunching and crackling in the background as he munches on his breakfast. I want to review what we know about Lewis structures and how to draw them, and also talk about how to draw Lewis structures for polyatomic ions. So hopefully you remember that word, polyatomic, or that term, polyatomic ion. Okay, so this is when you have atoms bonded together, the entire thing with a charge. So, for instance, this is the polyatomic ion, which is called sulfate. It's got one sulfur atom and 4 oxygen atoms, and this entire unit has a -2 charge on it. Okay, so all 5 atoms function as a unit, and this particular ion has a 2 negative charge. Okay, there are positively charged polyatomic ions, one being ammonium, NH4+. So hopefully you remember these two. They were a couple that you would have memorized a while back last semester. Okay, so this is a nitrogen atom and 4 hydrogen atoms, the entire unit with a +1 charge. So how could we do a Lewis structure for a polyatomic ion? These are atoms that are bonded together. Notice that everything in here is nonmetals. Occasionally you get a polyatomic ion with a metal. For instance, there's a polyatomic ion permanganate. Okay, so occasionally you get things with metals in them that actually are polyatomic ions, but normally pretty much all polyatomic ions are nonmetals bonded together with the charge. So they're kind of like covalent and ionic all at once. We're going to focus on this covalent part though first, and then deal with the ionic part. So how can we draw a Lewis structure for a polyatomic ion? So let's focus on sulfate first, and let me scoot down the ammonium, and we'll focus on that in just a second. So here's ammonium, we'll scoot him down. So for sulfate, okay, so our process for drawing Lewis structures is count up the total number of valence electrons, and this is really identical to what we did before. So sulfur, let's see, I need to make a new periodic table packet, but here's sulfur, it's in group 6A, so it's got 6 valence electrons, and oxygen is also in group 6A, 6 valence electrons. So for sulfate, we've got, here we go, we've got 6, it's going to let me write 6 plus 4 times 6. Okay, so that's the sulfur atom, these 6 here, and then 4 times 6 for the oxygens here. Okay, so 6, 12, 18, 24, 30 is like 5 times 6. We've got 30 valence electrons. Now, the entire thing is composed of these atoms, but it also has a -2 charge. Now, take a second. What are the subatomic particles with negative charges? They're electrons, of course, right? So a sulfate ion has these atoms and 2 extra electrons. So we need to include these 2 extra electrons in Lewis structure. So it might seem a little strange to add something that's negatively charged, but I'm just counting up all the electrons All right, I want to count up all the electrons that are there. So there are 32 valence electrons in the sulfate ion. 30 from the sulfur and the 4 oxygens, and then 2 more because this entire thing has a -2 charge. Okay, so this is sort of like the covalent part, right? 30 valence electrons from these atoms sharing electrons, and then they're going to share 2 extra electrons that came from somewhere else. We don't really know where those 2 this dog's like rolling around from somewhere else. We don't really know where those 2 extra electrons have come from, and it doesn't really matter. What matters is they belong to sulfate now, and it's got 32 electrons. So we're going to attach the atoms together to a central atom. Sulfur makes the most sense based on previous lessons. We put sulfur in the middle. I've used up 2, 4, 6, and 8 valence electrons. So I've used up 8. I've got 24 left. And so I'm going to place these 24 electrons, and I'll make those green for you so we can keep track of them. I'm going to place those 24 electrons as lone pairs. And by the time I try to satisfy the octet rule for all the atoms, you'll notice that I run out perfectly. Right? I've distributed those 24 electrons around the oxygens. So each oxygen has an octet. The sulfur also has an octet. Okay, so let me highlight oxygen's octets. Those are oxygen's octets. He's chewing on his crate right now. This is really funny. He's actually outside of his crate, chewing on his crate. I think he has a lot of anger towards the crate. Nah. Okay, and then here's sulfur's octet, right? Those electrons that are around it, okay? Now, so that's our Lewis structure. We've met all the conditions. There's the right total number of electrons, and we also have octets for all the atoms. Get down. Hup. Okay, this is going to be like a play-by-play with this dog here. Sit. Good. Okay, so there's one other step we need to do for a polyatomic ion. Once we have the structure, what we're going to do is put the entire structure in brackets and designate, state what the charge is. So let me erase these, put that one little extra electron back there. And we put brackets around the whole thing, and there's the charge. Boom. That's sulfate's Lewis structure. Let's try it with ammonium. Okay, so he's got a toy. You're going to hear some flapping around. Okay, so nitrogen's in group 5A. It's got 5 valence electrons. Hydrogen, 1A, 1 valence electron. There's 4 of them. So the atoms bring together 9 electrons. But this ion has a positive charge. And what that means is somewhere along the way, it's lost. It has lost 1 electron. Okay? And so we need to update the total number right here. It's lost an electron at some point. So ammonium has 8 valence electrons as well. And not as well. It's very different than sulfate. So I'm a little bit distracted, sorry. We're going to attach these atoms as single bonds to the nitrogen. And by the time we've done that, notice that nitrogen has its octet. Okay. And the hydrogen has its duet. Hydrogen follows the duet rule. Okay. So everything's worked out. We've used up all 8 valence electrons. There's none left. And so we don't have any lone pairs in this structure at all. And so we're done. So all we have left to do is put brackets around the entire thing and state the charge, put it in the top right just like we would for an ion. Okay, so your work that I would like for you to focus on today, I'd like for you to attempt these 3 polyatomic ion structures, and then move on to this page in your packet, and I'd like you to complete these ones here. There's not, we're going to skip a few of them. Don't worry about number 12, number 8, or number 9, or number 10. That's an ionic compound actually with a polyatomic ion. All these other ones you should attempt. And honors classes. The ones that I'm circling here in red, those are for you only. Okay, so honors only. Okay. And all the other ones, these are for everyone. Okay, regular and honors. Okay. So please complete those, and that will be today's lesson. You can check back later to view the key for some of them. And please schedule a Zoom meeting with me if you need to. Bye.